Hello, welcome to this lesson. This lesson is going to summarize what we have done, the trig functions on special angles, right? In the past lessons, we have done trig function on, the special angle pi over 6 as a reference angle, and pi over 4 as reference angle, and then pi over 3 as reference angle. And we also have discussed terminals on the x-axis. Why these special angles, right? These special angles are introduced to help us to understand the definition of trig functions, okay? So these special angles are not the objective, okay? The centerpiece is a definition of the trig function. So this piece is really the definition. This piece is the centerpiece of trigonometry, really. This piece, right? Standard position, angle measurement, reference angle definitions. I call it ARD, okay? A for angle measurement, R for reference angle, D for definitions of all 6 trig functions. These 3 make the 3 pillar, okay? The 3 pillars. The 3 pillars of trigonometry. And these 3 pillars are served by the special angles. Okay, the special angles in the process when we were doing it, I hope you guys do watch those other 3 videos, those recordings. I keep emphasizing the definition of trig functions. And if all three lessons combined and we summarize, and we get to this circle, okay? I got this circle from the internet, and I found it pretty good. So I have been using the same color tone, okay? The red is for X, the blue are for Y, and X are cosine, the red are cosine, the blue are the sign. So now, to summarize what we have done, right? For the pi over 6, 30 degrees as reference angle, right? So we have 4 cases: pi over 6 as special as reference angle, pi over 6 as reference angle, pi over 6 as a reference angle. So these 4 cases can be seen on this picture. Okay, we see them right here. There's one here, right? And there's another one over there. And in 3rd quadrant, right? And the 4th quadrant. So that's pi over 6. So we worked out all 4 coordinates. And then we found cosine, sine in each case. So for any terminals that, in this situation, okay? And these special angles are serving the 3 pillars, not the other way around. So anytime you're dealing with trig questions, the first thing you should be thinking of are ARD, okay? Because in a lot of cases, we don't have special angles. We have just angles in between the special angles. But why special angles are used often? Because they are the simplest academic questions. They're the simplest academic examples, okay? If we use other, terminals other than the special terminals we discuss here, it would have been even more complicated. The number will be even, will be messier than we are dealing with right now, okay? So that's for the case of pi over 6 special reference angle. Okay, so all of these special reference angle pi over 6, pi over 6. So we have that case covered, right, by one lesson. So you haven't watched it, please do, okay, because the method in the study is very important. It's very important, okay? So let's look at pi over 4, okay? For pi over 4, okay, 45 degrees. The 45 degrees, right? It's in the second case, right here. First quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, we have these 4 cases. So all of these coordinates, okay, and you can find them on this picture, Okay, on this picture. Where do you see them? The 45 degrees, right? Or pi over 4, pi over 4. So this is pi over 4 reference angle, pi over 4 reference angle, right? This is a reference angle. And the angles can really be, very different as long as they terminate on these special angles. Okay, so this second case, when we discussed in the previous lessons, and you can see all of these coordinates consistently. The red are axes, you see the red are axes, and the blue are y's, and the blue are for sine, and the red for cosine. Okay, so now let's look at pi over 3. In the case of pi over 3, right, we also have these 4 cases, and we had a detailed discussions about them, and you can find these coordinates. You can find these coordinates on that unit circle we just shown you, right? Right here. Okay, and what are they? So we see them. This is pi over 3 as reference angle, which is right here, right? This angle, pi over 3. Another reference angle, pi over 3. Another reference angle, pi over 3. Okay, this is a reference angle, pi over 3. Okay, and this one over there. So the coordinates are also all there. Okay, so when we look at these, you always have to have standard position in your mind, which is the green here, and the 3 pillars of trigonometry. So this triangle is serving the 3 pillars of trigonometry. Last but not least, okay, in the lecture we discussed about special angles. Okay, special angles. So I wish you guys to take a look at these, right? When the terminals are on the x-axis or y-axis, when terminals are on the axis, right? So it could be this case, right? The terminal is here. Okay, what are the angles with terminal over here? And that can be 0, 2 pi, 4 pi, and so on and so forth, right? And the coordinates is 1, 0. Cosine is 1, sine is 0. And in this case, right, you see we have this table set up. We did this table, right? We have cotangent is undefined here, okay? Cosecant is undefined here. Cosecant is undefined there. Hold on, I think I need to put something there, okay? Yes, I think I might have missed something here. All right, so I should insert a row over there. Wait a second. I should put it over here, okay? Because it's a little bit hard to tell which one. Okay, so insert a row there. Okay, so this is a sine, and this is a cosine, and this is tangent, and this is a cotangent, and this is a cosecant and secant. Because in the undefined case, you don't know what is undefined. Okay, you don't know what's undefined. So for the cotangent is 0, for cotangent is 0, right? So this tells us for cotangent is 0 or 2 pi, 4 pi, these are undefined, right? Cosecant, and those are undefined. So this actually leading us to, our future discussions about domain, okay? The second terminal, so we just discussed the terminal which is overlapping with the standard position. How about the terminal is over here? What are these angles? These angles be pi over 2 plus 2k pi, right? You go around, right? You get to pi over 2, and then you go around, you come back to pi over 2. And these angles, right? And we have sine is 1, right? It's because red is x is a cosine, blue is sine, and so we have sine, cosine, and tangent is undefined because in this case, cosine is 0. So tangent will be undefined at these places, okay? Undefined at these places. So you can look at horizontally, vertically, and cotangent is fine, and cosecant is fine, but secant is undefined because the denominator is, the x is 0. You see, by definition, so let me write it down, right? Let's go right down further. If we want to relate to the definition, right? X sine is y, cosine is x, right? Tangent is y over x. You see, they're so closely related to the definition. So we need to constantly have definition in our mind, right? And cosecant is 1 over y, right? And the secant is 1 over x. 1 over x. So these are, of course, on unit circle, right? So we actually already figure out the domain. We have already figured out the domain, okay? But anyway, we're going to have another way to approach domain here for the other terminal, okay? For the other terminal now, right? Then the third terminal in our consideration will be the one that overlaps with the negative direction of x-axis. This is the terminal. And these angles will be pi, 3 pi, 5 pi, and so on and so forth, right? And in this case, we have a -1, 0, right? -1, 0. So sine, cosine are determined, tangent is determined, right? Tangent is y over x, y is 0, therefore tangent is 0. Cotangent, okay, which is x over y is 0, undefined, right? Cosecant, because we got 0 as denominator, y is 0. So any one of these with y as 0, they will be undefined. Secant is -1, okay? Secant is -1, we just go by definition, 1 over -1, that's on -1. The last terminal, the last special terminal will be here, right? The last special terminal. So what are the angles that terminates here? Well, -pi over 2, right? 3 pi over 2, right? And plus 2k pi. There are many of them. There are many of them. But in this case, we have 0, -1. So cosine is 0, sine is -1, right? But x is 0 here. So in the definition, anywhere we have x as a denominator, those will be undefined, right? So you can look at horizontally, you can look at vertically. Now we can see if we look at vertically, tangent, okay? tangent angle cannot terminate on the y-axis. Okay, y-axis, this terminal. It cannot be, they will be undefined. So for tangent, this line, the entire y-axis cannot be the terminal of any angle, any input angle for tangent. For cotangent, right? Cotangent when y is 0, when y is 0, the entire x-axis cannot be terminal for cotangent for any input angle. Okay, that input angle cannot be x-axis, whether the positive direction or negative direction, it will cause undefined, right? Cosecant, the same thing. Secant, right, has, because x equals 0, and that will be the y-axis, right? So if you think about it, right, constantly reflecting on the definition allows you, you don't have to memorize anything at all. You don't. All you have to do is just identifying these points, and you can just figure it out by yourself on the spot. All we are relying on here are definitions. So definition is really, you know, the centerpiece. And of course, the definitions are right here. And these definitions are set up on the stage set, right? What are the stage? A and R, right? If you talk about standard, you know, standard position, right? Standard position, that's fine too, yeah, right? So it's on angle measurement and reference angle. So these three pillars, right? ARD really, you know, is something we need to constantly reflect on. Okay, and the other reason that we're gonna we stress that the special angles are in service to definition. Okay, so let me write down all the special angles are in service to the three pillars, which is ARD. Okay, angle measurement, reference angle, and definition. All the special angles are in service. Are there cases that, how about non-special angles, right? Non-special angles. Most of the time in real life, when we use trigonometry to solve a real question, they're not special angles. Okay, how do we handle them? We handle them by definition, using the, you know, we have practiced enough using special angles to, you know, to work with the definition. So when we have non-special angle, we can apply the three pillars to the non-special angles. For example, the first example we did, right? The 3, 4, 5. That was a non-special angle for sure, right? So, and for good measure, that, you know, that question is, being able to do that question, you have to use definition. And for the, you know, for the latter special angles, then of course you need to reflect on the definition over and over and over again. And I hope I have emphasized enough without put you into boredom, just to make sure you understand what I meant. If you have any questions, okay, because from this point, we want you to understand the definition fully and completely. And we will come back. We'll come back to see what else can be digged out of the definition. Okay, our focus, right? This semester, our very focus is the definition, is the three pillar. Our very focus is the three pillar. The special angle serves that. So we will constantly go back to the definition, and we will discover even more information about, for ARD. From ARD, we'll discover a lot more, such as domain range, one-to-one function or not, increasing, decreasing, right? And what else? Even function or odd function. So we're going to discuss all of these concepts. We're going to discuss all of these concepts, and all of these concepts will be useful for your future classes. Okay, so without further ado, let me end this lesson, and I will see you next time. Thank you for watching.